All right, so let's take a look at page 2. So page 2, our next question says 5 U.S. domestic flights are randomly selected, and the table lists the probabilities for the number that arrive on time. Assume that 5 flights are randomly selected. So our random variable in this case is any possibility that we could have that arrive on time out of those 5 flights. So we could have none of them arrive on time, 1, all the way up to 5 arriving on time. So we have our different probabilities from that. Now the first question says, does this table describe a probability distribution? Why or why not? So you have to remember what the conditions are for a probability distribution. And there's 3 of them. So remember, the first condition is is the random variable numerical? Well, yeah, we have numbers for our random variable, so we're good there. What about the second condition? Remember, the second condition is that the sum of the probabilities equals 1. So I'm going to have to bust out the calculator for this one. Now remember, 0 plus doesn't contribute anything to the sum, so we can just skip that one. So 0.006 plus 0.048 plus 0.198 plus 0.409 plus 0.338 equals. So 999, which remember is good enough in this case. Because we have this very small one, which does add a little bit to it, it's going to get us close enough to 1 where we can accept it. So we'll say yes. All right, so we got 2 yeses. And then the third condition is that each probability has to be between 0 and 1 inclusive. So remember, inclusive means including. So if we look at all of our probabilities, none of them are negative, none of them are bigger than 1, so we're good on that one as well. Now technically I should have said from the probability from 0 to is between 0 and 1 inclusive for all x, or for each x. So yes. So table is a probability distribution. All right. So we have a probability distribution. So we should be able to find the mean and the standard deviation. So we have some extra columns built into this table. So big question is what are they? What do we fill these columns with? So if you remember correctly, the first column has a title of x times p of x. So all you're doing is multiplying these 2 columns together. So we can do that pretty quick. 0 times anything is 0. We can multiply by 1. We can multiply by 2. We can multiply by 3. And we can multiply by 4. And we can multiply by 5. Let's see, okay, 490. So that fills in that column pretty quickly. And now what's the mean? Remember, the formula for mean is equal to the sum of x times p of x. So once you have this column filled in, all you have to do is add up that column. So let's see what we get. 0.006 plus 0.096 plus 0.594 plus 1.636 plus 1.690. 4.022. right. Well, what about rounding? That's the other big thing about these is rounding. Now remember, what are we finding here? This is the average, this is the mean, but it's the mean of your x's. So this is the average value of x. So we don't have any decimal points in here, so we only need a minimum of 1 decimal point in our mean. But it looks like it's going to round and stay at 0. So if you wanted to say 4.0, that would be acceptable. If you wanted to say 4.022, I would accept that as well. But you shouldn't just round it to the nearest whole number, because that's not the correct round-off rule. So, but 4.0 would be acceptable in this case. All right. So now for standard deviation. Standard deviation, we need these next two columns. So we're going to have x squared and x squared times p of x. So x squared, we're just squaring each of our random variables. So 0, 1, 4, 9, 16, and 25. And then we got to be careful, make sure we multiply this column times this column. A lot of people get confused and multiply these two columns together, and that's no good. So, well, 0 times anything is 0. 1 times that is that. 4 times that looks like would be 0.192. 9 times that, let's see, 1.782, I think. Now, I'll go through and double check these in just a sec, but let's just keep going. So we got 16 times that. So let's see, 6 point what? Let's see. Well, I'm going to be lazy and use a calculator. My brain hurts. I'm sure yours does too. So 1.636 times, oh, whoops, make sure I grab the right ones. So I need this column and this column. So 16 times 0.409 equals 6.52, oops, 4. All right. And 25 times 0.338, 8.450. Now let me just double check that one just to make sure. 9 times 0.198 equals, okay, so I was good on that one. All right, so now we got our table filled in. So now we got to find our standard deviation. So remember, the formula for this is a little bit yucky. So we need the sum of x squared times p of x. Then we need to subtract the mean squared. So here's our x squared times p of x column, so we need to add that up. So let's add that up real quick. And again, I can put the sum here. So we got 0.006 plus 0.192 plus 1.782 plus 6.544 plus 8.45, 16.974. All right. So we've got our sum in here. We have our mean plugged in, but we got to square it and we got to subtract it. So let's do all that on the calculator. So we got 16.972 minus 4.022 squared equals, so we want to take the square root of that. So I'm just going to jump right to the square root. So 0.8919 and so on. All right. Now, same kind of rounding that we did up here. We want 1 decimal place. So let's go 1 decimal place here. So this would be 0.9. So 0.9. So 4.0 and 0.9. Now again, we could round this to 3 decimal places like we did this one, but that's typically what you would want to do. You always want to try to match up the number of decimal points between your mean and standard deviation, within reason. Sometimes your mean just doesn't have any, so the standard deviation will have some as a result. All right. So, but that's our mean and standard deviation. Let's take a look at number 8. Use the range rule of thumb to identify the range of significant values for the number of flights that arrive on time among 5 randomly selected flights. Based on your results, is getting exactly 2 flights to arrive on time among 5 randomly selected flights significantly low? Why or why not? Well, let's get our min significant value, which should be our mean minus 2 times the standard deviation. So that's 1.8. So 4 minus that is 2.2 flights. And that's the other thing I didn't do. We should put our units. Anytime you have a mean and standard deviation, there's going to be some units. So flights for both of those. Shame, shame, shame on me. So there's our min significant value. And then our max significant value. So now we got to add 2 standard deviations. So that's going to be 5.8 flights. So now that we have those cutoffs, what can we say about 2 flights? Is 2 flights significantly low? Why or why not? What do you think? Here's our cutoffs. You should be saying it is significantly low. So 2 flights is significantly low because two is less than 2.2. 2.2 is our minimum. So as soon as you fall below it, that means you're in that low range, and that is unusual. You wouldn't expect that to happen. If it had been anywhere between 2.2 and 5.8, that's not significant. We would expect that to happen. Anything above 5.8 would also be unusual. It would be significantly high. So that's the idea behind this. So in this case, 2 is less than our minimum, so it is significantly low. All right, let's take a look at this last one, and then we'll cut this video down and go to the next page. What is the probability that at least 3 of the 5 flights arrive on time? So now we just have to use what's in the table. So remember, at least 3. So be careful. At least 3 includes 3, but it's 3 and up. So you have to go 3, 4, and 5. So looking up at your table, I'm not going to bring it down, but if you look up at your table, probability of 3 is 0.198, and then 4 is 0.409, and then the last is 0.338. So we have to add up all of those probabilities. So 0.945. Okay. At most 1 flight arrives on time. So at most 1. So at most also includes 1, but it's 1 and below. So we need the probability of 0 plus the probability of 1. Probability of 0 was 0 plus. Probability of 1 was 0.006. So remember, this doesn't really add anything. So 0.006 should be your probability. Between 2 and 4 flights on time inclusively. So remember, inclusively means including. So we want the probability of 2, of 3, and of 4. So that's going to be 0.048 0.198, 0.409. So let's add those up. So 0.655. All right, so there was a lot to this page, but again, just try to break it up into smaller chunks. Knowing when you have a probability distribution, formula for your mean, formula for your standard deviation, range rule of thumb, which is a different way to look at significance than the 5% rule. So if you don't have means and standard deviations, then you can't use the range rule of thumb. You have to use the 5% rule. And then, of course, just reading the probabilities and making sure you interpret those phrasings correctly. So that's going to be important as well. All right, so we'll stop here and we'll see you in the next video.